Civil Engineering Academy. Hey, what is up, everybody? Welcome back to Civil Engineering Academy. Today we're solving a problem from structures. It states find all the zero force members in the truss shown. We've done a zero force member truss before, but these are very confusing sometimes, so we're going to do a couple of them. So let's take a look at this. And the first thing I'm going to do is go over the rules if we can remember them. The first rule that I talked about was basically if you have no pins or rollers on a member and you have no external forces, and you're coming to a point like this, and this is not 180 degrees, both of these are zero force members. So I can tell right off the bat that looks like it applies right over here, CD and DE. Okay, rule number 2. If you have two collinear members and one is a zero force member, the other is a zero force member. Okay? That's simple. 3. If you have two collinear members and one sticking out, that third one is a zero force member. And the other rule, I guess, that goes along with that is that if you had two sticking out, not necessarily at 90 degrees, and you found out that one of them is zero force members, somehow it's connected somewhere over here, then that other one is a zero force member because it follows this rule. Okay? So let's take a look at this. I'm going to start at joint D. So if you were to take joint D and look at the sum of the forces in X and Y, you would get that these two are zero force members. That is CD and DE. Or in this case, we just follow rule 1. So boom, done. If we look at joint E, that we have an external load here, so CE is not a zero force member. But if we look at EF, that is a zero force member because we've got two collinear members here, and this one is a zero force member. Okay, so EF, zero force member. Let's go up to joint C. We've got a load going through this now because of that external 10 kip load. That means that CF is not a zero force member, neither is CB. Okay, those rules have gone to crap because of that external load. If we look at joint F, we already said that CF is not a zero force member. And because of that, BF is not a zero force member, neither is HF. If we look at G, we've got a load, we've got a reaction here because this is a pin going through GF, okay? So that's not a zero force member. But look, you got to look at AG. There's no reaction going through AG at this pin, so I'm going to say AG is a zero force member. Okay? If you were to look at A, you would assume that there was a load going through it. But to make this work, if you look at G, there is no load. There's no load acting through that. So AG is a zero force member. AB is not a zero force member because you've got this force going through it. If you look at joint F or H, right here, you've got these two collinear members, AH and HF. That means HB is a zero force member. Let's go HB. So I've got 1, 2, 3, 4, 5 zero force members here. And that's going to correlate to 1, 2, 3, 4, 5 DC, DE, EF, HB, and AG. I got these two backwards. But all right, so basically this gives me letter A for this one. And this is another good zero force members problem. I encourage you to head to Civil Engineering Academy for more tips and tricks related to the PE, and hopefully this helped you out. Thanks, bye.